Welcome to our Algebra 1 EOC review for Livingston Parish. Today we'll be working on Texas Staars Algebra 1 EOC, questions 32 to 54. I appreciate your sticking with us. I appreciate you joining us. And I am so thankful that you are still working on your EOC. I hope that you are understanding these questions. It's important to understand them, especially if you missed them. You want to go back and reanalyze them and rework them to make sure that you understand what's going on, because all of these states are presenting concepts that are key to doing well on the Algebra 1 EOC. And so you'll need to be able to do that in order to score well. Okay, let's start with number 32. They want to know which of these is not a function. Okay, first of all, we know on this one, it's failing the vertical line test. Okay, each member of the domain is being used more than once, so that is not function. This one, if the slope is multiplied by -10, so you have 1/5 times -10. 5 goes into 10 twice, we get -2/1 or -2. Okay, and we know that those two lines will intersect. The slopes are not the same, so they will intersect. No way they can be parallel, the slopes are not the same. They're not doing anything with the y-intercepts, so it won't be moving any units up. They're only multiplying the slope by 10, so it can't be those. The only choice it can be is A. In this problem, they tell us we have a quadratic function, and they tell us that one of the solutions is 3. Okay, and they give us some other values, okay, and we're not sure, okay, it might be, this one looks like if you graphed all that, it would be concave down, because when x is 0, y is 5.25. Okay, so it looks like it's concave down. We know that the zeros of a quadratic and the x-intercepts and the solutions all mean the same thing. If the x-intercept, y is always equal to 0. The solutions are where it's going to cross the y-axis. Right here, when y is 0, x is -7. So the other 0 has got to be -7. Okay, this one, they tell us the total cost is a function of the number of photocopies. What is the independent variable? Well, first of all, the cost depends on the number of photocopies, so the number of photocopies has got to be the independent variable. Okay, so your answer, okay, would be D. Okay, the independent variable is the total number of photocopies. A lot of times in an independent-dependent variable situation, the thing that you have the most control over is going to be the independent variable. Here you can choose how many photocopies you want made, but you do not have control over the cost. The cost is going to be, it's going to depend on the number that you had made. Okay, so that's why independent is done that way. This one, what I did was I started connecting these. Okay, 311, -1, 3, 5, 15, and I hope that you do a better graph than that. But anyway, okay, you'll see that they make a straight line. Okay, we know that this is linear, so it's got to be F. That's exponential. That's where x starts off small, goes up large. X squared, that cannot be the model. That would be a parabola. And if you recall square root x's, they're half of a parabola rotated 90 degrees. Okay, so that's got to be our answer. Okay, in this one, the average rainfall is 33.2 inches. Okay, but so far they've only received 9.7 inches. That's been a dry year. But some rain is coming, and they want to know how many additional weeks it would take for the city to reach its rainfall. Okay, so what we're going to do is, first of all, um, I'm going to subtract that 9.7. Okay, and when you do that, uh, okay, they need 23.5 more inches of rain to reach that rainfall. Okay, let's do the numbers. First of all, if it's 1.5 inches per week, that'd be our rate of change. Okay, we want to know how long it would take them to get that 23.5 additional inches of rain. Okay, and what you do is you divide both sides by 1.5. And on your calculator, if you do 23.5 divided by 1.5, you get 15.6 repeating. So at the most, it's going to take 15.6 weeks for them to get that rain. That knocks out choices A and D. That's too much. Now, if they get more rain, say 2.1 inches per week, it won't take them as long to reach that 23.5 inches of rain that they need. We divide by 2.1, and when you get that, do that number, okay, you get 11.19 weeks. So the answer is going to be between 11.9 and 15.6. B is your answer. Okay, this question okay. All right, which one is true? Okay, they're comparing quiz 2 with quiz 1. Let's look at this person. On quiz 1 they made a 30, but on quiz 2 they made a 10. Okay, on this person, on quiz 1 they made about 25, but quiz 2 they made a 20. And if you look at all of these numbers here, even here on quiz 1 this person made a 50, but there the class average was 35. So all the way up to 50, you'll see that, yes, okay, the points for quiz 1 here was 50, but it was less than 50 here. Okay. So your answer would be J. Number of points scored is going to be less than the number on quiz 1 for any student who scored 50 points or lower on quiz 1. Very, very wordy problem. I don't think we'll see anything this wordy on Livingston Parish. This is what we call a word salad, all of those questions. And I don't think you'll have any word salads on our Louisiana EOC. All right, let's look at this one. There are no more than 5,000 cars transported by the ferry daily. What's the range of the function for this situation? Okay, well, at the most, okay, if there's 5,000 cars, cancels, 2 goes into 500, 250. So on their busiest day, okay, all right, there'll be 250 cars taking, let's see, 250 trips. Now, some days ferries are closed. There might be like a day where that ferry is not open. Okay, if no cars are there that day, okay, then there'll be no trips. So the least number of trips they could take would be 0. So the range would be all the integers from here. Okay, some folks might have thought this is the case, but that's not the range, that is the domain. Remember, domain is the independent variable. It's kind of like the x. That's what you plug into the function. That's your inputs. The range is like your y number. It's the outputs. So that's why we have to have this number here. Okay, looks like we've got a system in this problem. It says the number of cupcakes I'm going to let K stand for the number of cupcakes. It was 4 times more than twice, 4 more than twice the number of cookies. I'll let C stand for cookies. This next sentence tells us that 52 total were sold. So the number of cupcakes, we're letting that be K, plus the number of cookies sold, we'll let that be C, was equal to 52. All right, and we have a system. So we're all going to need to solve this system. I will copy down this, the total, 52. All right, I need to line my system up so that I can do the linear combination. On this equation, I'm going to subtract 2c from both sides. So you have k minus 2c equal to 4. Okay, since they want me to solve for the number of cupcakes, or k, I'm going to eliminate the c's because they don't want to know anything about those. I notice that it's negative 2c. If this was positive 2c, I could just add and get rid of the cookies. So I'm going to multiply this top equation by positive 2. That gives us 2k plus 2c equals 104. I'm going to keep the bottom equation as it is. And now I can combine my two equations. That gives us 3k. Those cancel, equal 108. Then we're going to divide both sides by 3. And when you do that, you get 36. So there were 36 cupcakes sold. If they wanted to know how many cookies were sold, of course, we could go back and plug that into one of these equations and plug in 36 for cupcakes and solve for cookies. Okay. All right, it says these 2 points are on the graph of a quadratic equation. Remember, that's like a parabola. And we don't know exactly what the parabola looks like, concave up, concave down, but we know that those are 2 points on it. We also know that parabolas or quadratic functions are symmetric. And since they are symmetric, the axis of symmetry goes down between those 2 dots. Whatever you have on one side, that side of your parabola, you have on that side. So what we need to do is we need to know the equation of this line here, and what we do is we find the midpoint. Midpoint, midpoint, what do? Add them together, divide by 2. I'll say that one more time. Say it with me. Midpoint, midpoint, what do? Add them together, divide by 2. So we're going to do the midpoint between negative 6 and 0. Negative 6 plus 0 is negative 3 divided by 2. Negative 6 divided by 2 is negative 3. So where x is negative 3 is where you have your line of symmetry. Vertical lines, that's x equals something, and A is the answer. It's the line x equal negative 3. Okay, here we are. And just looking at the data, I can tell that the number of times these are all increasing by 2. These are increasing by 52. That tells me the data is linear, and if I can find out the linear function, I can use it to predict anything they want. So I need to know the linear function that's represented here. Well, first of all, if we divide 52 divided by 2, that gives us our change in y over our change in x, which is 26. That tells us that every time they use the dishwasher, it washes 26 dishes. We need to know the y-intercept to complete this. Okay, well, we know that that was a step up of 2 there, and then we can subtract 52 to get back to 0 here. So the y-intercept was 0. So this is just the line y equal to 26x. It makes sense that the y-intercept would be 0 because if you're not using the dishwasher, you're not washing any dishes. Okay, what we're going to do now is they want to know how many dishes will be washed when you use the dishwasher 9 times. So 9 times 6 is 54. So after the 9th use, you will have washed a total of 234 dishes. Okay, they want the numbers in this pattern. And I notice all these fractions. I'm going to change the 3 and the 12 into thirds. So I know that 3 over 1, if we multiply top and bottom by 3, 3 can be written as 9 divided by 3, or 9 over thirds. 12 times 3, that's 36. So 12 is the same as 36 over 3. Okay, and now I can kind of see what's happening. If n is 1, okay, and then n is 2, n is 3, n is 4, it looks like they're squaring n and just dividing by 3 each time. When n is 5, they square that, they get 25. When n is 6, they square that, get 36. So the answer would be B. All right, and we've got this tank. It's being drained. Okay, and it says if the rate is changed to 3 inches per hour and the initial water level stays the same, which is 12 inches, okay, how would the time be affected? Okay, so first of all, what we're going to do is, you notice the rate of change here is, okay, it's down 2 to the right 1. Okay, so currently the rate of change is negative 2 inches per hour. Okay, they want us to change this to negative 3 inches per hour. Okay, well, first of all, let's go ahead and write the function for this one. As it's written, y would be equal to negative 2 h hours plus 12. But we're going to change this so that the rate of change is 3 inches per hour. So our new equation is going to be y equal negative 3h plus 12. Okay, so one of the things you can do is, you can see here it takes 6 hours. It took up 6 hours to empty it. What you can do is go ahead and plug in 0 for y, because when the height is 0, it'll be empty. Subtract our 12. And you get h is equal to 4. Okay, all right. This is a little tricky. It's not 4 fewer hours. It's in 4 hours that tank would be empty. So it took up 6 hours to empty it. Now it's only going to take 4 hours to empty it. So it would take 2 fewer hours. Another way you could do this is you could just graph what we found here. Okay, you could do it graphically. Starting at 12, you go down 3 over 1. In 1 hour, that's what would be left. Okay, the next hour, go down 3 over 1. Go down 3 over 1. Go down 3 over 1. And once again, it takes 4 hours to empty that tank. It originally took them 6 hours. 6 minus 4 is 2. So you see you could use either the equation or the graph and get it right. Okay, we've got an office building that's going to have a tower on the top that's 15.85 meters tall. And then it's going to have several floors. And each of those are going to be 3.9 meters high. Okay, and we let n be the number of floors. Well, every time you go up a floor, you're going up 3.9 more. So your rate of change is going to be 3.9. The y-intercept has to be 15.85. That's that tower on top. So the height on any floor is going to be given by this equation. So B is our answer. Okay, what are the x-intercepts of this quadratic function? What we need to do is, okay, x-intercepts are the same thing as the zeros. That's where y equals to 0. We need to solve this equation. Since it's degree 2 or higher, we need to make sure it's equal to 0, which it is, and then we need to factor. Okay, the leading coefficient is not 1, so we're going to have to do 5 times -1 and get -5. We have to think what multiplies to give us -5 adds to give us +4. Well, that would be +5 times -1. So we're going to need to rewrite 4x as 5x minus 1x. And now factor by grouping. These two factors have 5x in common. That will leave you with x plus 1. These two factors, remember when the first, second, and third number in factoring by grouping is negative, your greatest common factor is negative. -1 times x is x. -1 times negative is +1. Okay, we combine those. X plus 1 is in common. You're left with 5x minus 1 equals to 0. By our zero product factor property, we know to take the opposites. So if x was -1, -1 plus 1 would be 0. If x was +1/5, okay, then 5 times +1/5 is 1. Take away 1 would be 0. That would give our answer. So our answer is -1 and +1/5. Okay, let's look at this problem. Okay, every time you add 2 plates, the weight goes up 70 pounds. All right, so if we subtract 70 from 115, okay, we get 45. That tells us that when there were 0 plates on there, that bar weighed 45 pounds. If they asked for a linear function, our rate of change would be 35x, because 70 divided by 2 is 35. Each of these weights weighs 35. And then we know the bar weighs 45. Okay, remember range, okay, that's the y numbers. So there they are. Okay, which set of ordered pairs contains only the points that are on this graph? I'm just going to start plugging them in and see which works. Okay, I know this was, if I plug in -3 for x, I'm going to get -27 for y. Let's see if that's right. That'd be 12. Okay, and I just plugged in -3 for x. Well, that's +9. And I get 21 for y. I was supposed to get -27 for y. That doesn't fit. Okay, let's go to the next one. 12 minus 3 times -18. I'm supposed to get 10 for the answer. Okay, that'd be 12. -3 times -18 is +54. That's 66. That's not right. Can't be it. Okay, let's try the next one. 12 minus 3 times -5. Okay, because I plugged in this -5, that's +15 plus 12, that's 27. That one worked. Let me try the next one. 12 minus 3 times -1. I'm supposed to get 15. And let's see, if you multiply -3 times -1, that'd be 12 plus 3. That does give you 15. That one worked. Last one. Okay, that'd be 12 minus 24. That is -12. So C is the answer. Okay, which can be represented by this graph here. First of all, I noticed that the rate of change looks like it's 1. So I need something with a rate of change of positive 1. I notice the y-intercept is b. It is a solid line and it's been shaded up. And look, there it is for us right there. Okay, the slope is 1. Solid line, got the equal to. B, got the y-intercept b, and they've shaded up. Okay, which is equivalent here. First of all, I see negative exponents. And one thing I like to do is when I have negative exponents, I like to switch them over and make them positive. And we know that if we move y to the negative 4 down to the bottom, it becomes y to the positive 4. We move this to the top, it becomes y to the 6th. Okay, now we're ready to start dividing. 12 divided by 3 is 4. We know that when we are dividing like basis, we subtract the exponents. You have more on the top than on the bottom, so you're going to have x to the 4th on top. y6 minus y4th, that's y2nd. You had more on the top than the bottom, so it goes there. z3rd, 3 minus 2 is 1. You had more thirds on the bottom than on the top, so the answer goes there, and D is your answer. Okay, what's the value of x when y equals negative 9? So they want us to plug in negative 9 for y and solve for x. Okay, well, I'm going to add 2 to both sides. So it gives us negative 7 equal to negative 4/5 x. We want to know what 1x is, the value of x. One of the ways to get rid of this negative 4/5 is to multiply both sides by the reciprocal, which would be negative 5/4. When you do that, the 4's cancel, the 5's cancel, negative from negative is positive. That gives you positive x. Over here, nothing cancels. Negative 5 times negative 7 is positive 35. 4 times 1 is 4, so we get 35/4, which is h. Okay, which expression is equivalent to that? My first thought on this one was to factor it, but then I realized the leading coefficient was negative. It's hard to factor trinomials when the leading coefficient is negative. I think what I'm going to do is I'm just going to distribute these out and see which one matches that. So if we distribute that, we get 9x squared, and look, it's supposed to be 6x squared. That's no way it can be. Might be this one. Let's see. Negative 3x times positive 2x is negative 6x squared. And then that's going to be negative 3x times negative 1 is plus 3x. 4 times 2x is 8x minus 4. You get negative 6x squared plus 11x minus 4. That is your answer. By the way, they may ask you to use the FOIL method, or they may mention that on the EOC. That means the first one times the first one, the first one times the outer one, the two inner ones times each other, and then the two last ones times each other. So if you see FOIL, that just means distribute it all out. Okay, and our last question from tonight's homework. All right, if it's translated 4 units up, okay, which equation describes the new graph? Okay, well, the y-intercept was 4, but we're going up 4 more, so that gives you your answer right there. The answer will be 9x plus 8. Okay, that concludes our Texas Stars Algebra 1 EOC. I hope that you are still working hard on your Algebra 1. Please continue reviewing, practicing. It's almost over. That is not the light at the end of the tunnel we're seeing. That is the end of the tunnel. Thank you for watching, and you have a great weekend. Bye-bye.